contributes to achieving favorable political, regulatory, and industrial frameworks that allow satellite communication services to play their rightful role in connecting the world. The GSOA vision is to help policymakers improve the state of the world by, amongst other things, using satellites to contribute to the achievement of the SDGs. And we hope that we can really achieve this. Moving on, we can't really know where we are going until we know where we have been. So if you will bear with me, I want to take us back in time a little bit as to where this all started. And it all started way back in 1947, where a science fiction writer, Arthur C. Clarke, proposed in a magazine by the name of Wireless World, which was a very well-respected journal in the, I got to know it in the 1970s, but prior to that. And he proposed an article there, or he wrote an article there where he proposed that 3 satellites in geostationary orbit could provide coverage to the entire Earth. And that he then in this article describes how this could be done. So that's really where it all began, way back in 1945. The next step was in October 1957, when the then USSR launched the first artificial satellite into space, Sputnik 1, which was launched on the 4th of October 1957. It was a spherical satellite, 58 centimeters in diameter, with a weight of about 83 kilograms, and it had 4 whip antennas. And it was launched into low Earth orbit, which was probably the best technical capability available at the time, and had an inclination of 55 degrees. Now, Sputnik 1 sent back radio signals to Earth for 3 weeks before its batteries packed up. Being in low Earth orbit, it then aerodynamic drag caused it to re-enter the atmosphere in January 1958. So it was operational for 4 or 5 months. The next milestone was the first telecommunication satellite known as Telstar 1, which was launched by the US in July 1962. Again, it was spherical, slightly larger than Sputnik, 88 centimeters diameter, but weighed slightly less. Again, it was in a low to medium Earth orbit with a perigee of 952 kilometers, an apogee of 5,900. And this had a period of rotation of 2 hours, 37 minutes. The first geosynchronous satellite was launched in 1965 by Intelsat. Intelsat 1, also known as Early Bird 1, and it weighed around 35 kilograms. And as I say, this was the first geosynchronous satellite, and in fact broadcast the moon landings in 1969. Now, looking very briefly at traditional SATCOMs, and I think we're all familiar with this, and I'm going to go through it very quickly. Traditional SATCOMs was a simple bent pipe technology. You had a ground segment that transmitted signals to the satellite amplified the signal, changed the frequency, and transmitted it back to Earth. The ground equipment then received the signal, and it was then either direct to home or was retransmitted further terrestrially. Very briefly looking at satellite orbits, and this will also be totally familiar to all of you. We have the LEO, low Earth orbit, 400 to 2,000 kilometers, medium Earth orbit, 8,000 to 20,000. The geostationary orbit, which we are all familiar with, traditional satellite, much of the work is done there, direct to home, fixed satellite services and so on, approximately 36,000 kilometers above the Earth. Molniya orbits, which are not very widely used, which are highly elliptical orbits with about a 40,000 kilometer apogee. There are also, of course, suborbital orbits, which are also becoming more and more popular these days, with spacecraft launching, going briefly into space and then coming down again. And there are a number of applications for these, including space tourism. Touching very briefly on the various orbits, as we said, satellites in the GEO circle the Earth at about 36,000 kilometers, traveling from west to east, and they follow the Earth's rotation. And because they travel at exactly the same rate as the Earth, satellites in GEO appear to be stationary over a fixed position, which makes them then ideal for direct-to-home broadcasts. You don't need an antenna that tracks, and as was postulated by Arthur C. Clarke and then confirmed later through practical implementation, with 3 satellites, you can cover the entire Earth. The one possible drawback of geostationary satellites is their latency, which is of the order of around 500 milliseconds. And this, for fixed satellite services, is not a problem, but once you start looking at mobile services, this latency does become a problem. Currently, there are over 600 satellites in geostationary orbit, which emphasizes the important role that they play in our communication world. Very briefly on non-geostationary orbits, we have 2 orbits. We have the low Earth orbit, 600 to 2,000 kilometers above the Earth. A single satellite in low Earth orbit has a period of less than 2 hours, a latency of around 40 milliseconds as compared to the 500 milliseconds in GEO, which then makes these more suitable for mobile type applications and applications where low latency is required. Medium Earth orbit between 2,000 to 10,000 kilometers above the Earth. A single satellite has a period of around 12 hours, latency of 180 milliseconds, slightly more